Hello there, welcome to another one of Learn Extra's exam revision sessions. I'm Mark Ancelotti, and today I'm going to be working on statistics with you. Remember, statistics is now in both examination papers, so we're doing a little bit of paper 1, a little bit of paper 2. Really our focus today, data handling of paper 2. So let's dive in. If I just remind you that there are study notes that accompany this TV session, so try to get hold of those, work through those examples so you can make sense of what today's all about. Okay, so here's just a bit of a checklist. Remember that statistics has been divided up in the new CAPS curriculum into paper 1 and paper 2. Paper 1 contains probability and counting techniques. Paper 2 contains all the data handling, and that's what I'm really going to focus on today, is the paper 2 data handling component of statistics. For me, the data handling can be divided into 5 little components, and you're probably going to get a bit of every one of them. So let's just see how we divide it up. In grade 10 and in grade 11, you worked with grouped data. So remember, grouped data, we played around. You could find an estimate for the mean. You could find a median interval. You're playing with intervals. You could find the standard deviation of grouped data. Now, I mentioned standard deviation. That's one of the other things that we have to do. That was introduced in grade 11, but it's examined in grade 12. Standard deviation and also variance, which is just the square of standard deviation. Remember, the other thing that we've got to do is the 5-number summary. So you either have to calculate it or you have to represent it graphically, and that's in the form of a box and whisker plot. Box and whisker, as early as grade 10, you've been playing with them, but in grade 11 and grade 12, we talk about more interesting things like the skewness of your box and whisker plot and read certain things from there. Then, of course, with grouped data, we will often work out something called the cumulative frequency, which is an accumulation of the frequencies up to a particular point in time. If we graph the cumulative frequency on the y-axis, we get something called the ogive. And so we have to draw an ogive, and more importantly, you need to be able to read off values from an ogive. And that is an important concept. Again, grade 11, examined in grade 12. One of the big things in grade 12 is actually determining and sketching the line of best fit. Now, that's sometimes called a least squares regression line or residual line, the line of best fit. You have to be able to calculate, using a calculator, that equation for the line of best fit. You need to be able to draw it on a set of axes on your scatter plot, and you also need to calculate the value of R. R at school is Pearson's correlation coefficient, so we interpret and play with that R value. Now, all of these concepts are going to feature in the 4 exam questions that are put together for you today. So let's dive in and see how we do with those exam questions. This first exam question is a huge question, so there is a huge amount here, but it's revising many of the concepts from grade 11. So let's see what we're going to do here. I've got a frequency table, and this frequency table gives the weights of the first 55 millennium babies born in a city hospital. And the really nice thing is I can see the total at the bottom of the frequency column. And then over here, these are intervals. So these are different weight intervals, so anything between 1 and 1.5, between 1.5 and 2.0, and so on. And so generally for continuous data like we have here, we put in intervals and it's grouped. So let's find our questions. The first question says to me, calculate a cumulative frequency table. So a cumulative frequency table, so what I'm going to do is I'm just going to actually use the space over here. It's the cumulative frequency, and I'm going to go and generate some values. So the cumulative frequency is an accumulation of all the frequencies up to that particular point. So what we're saying is, how many babies are between 1 and 1.5? Well, 2. Now look carefully. What should be happening here is we're saying, how many babies were in weight below this final value? So how many babies weighed less than 2 kilograms? So it's everything up to that point. So it would be the 2 plus the 7, which then makes 9. Now when I get to the next one, what we're doing is we're saying, how many babies were actually below 2.5 from that lower bound up to there? So it's always saying, what's the running total? What's the accumulated frequencies up to that point? And the nice thing is, if this is always the total up to a point, all I have to do is say, well, add the 9 to the 10, and I'll get 19. And then add that 19 to the 14, and so I can go and work out the cumulative frequency. Just be aware, I've seen many nice exam questions where the examiner will give you partially completed table with some frequencies, some cumulative frequencies, and you have to go and solve for unknowns by working backwards or forwards. But to save a bit of time, I've already completed this cumulative frequency table. So let's go have a look here. If you've been working through the handouts that accompany this lesson, hopefully you've got exactly the same answers here. For me to know that I've done this correctly, the final value in the cumulative frequency table should always add up to the sum of all the frequencies. So the n value is the cumulative frequency. Now, if we are talking cumulative frequency in the examination, almost certainly you're going to go and draw it. When we talk cumulative frequency, I want you to immediately associate ogive. The ogive is the visual sketch representation that links cumulative frequency to your actual weights. Now, I've got a set of axes and I'm asking you to draw the cumulative frequency curve. And many students will go and start off at 0 there. And I'm saying, please don't ever do that. Sometimes you will need to go there, but other times you don't. So the first question is, where do I start on the x-axis? So I've got a whole lot of values along the x-axis. Where do I start? Well, go back to your table. You always start at the lower bound. So that's the lowest part of the first interval. That's where you start on the x-axis. Because what the table is telling me is if there were two babies that weighed between 1 and 1.5 kilograms, there's nothing before that. So we would start off at 1 on the x-axis. So go down to 1 on the x-axis. You wouldn't make such a big cross, but I'm trying to make a cross so it's clear on your TV screen at home. That would be the first point that I plot. Now when I'm going to plot, the cumulative frequency is always on the y-axis. So I'm plotting these as y values against each of these endpoints. So what we're saying is, even though there were two babies that were within this weight, we know that two babies were 1.5 or below. And if I know that I'm now getting to 2, we know that even though there were 7 within this category and 2 beforehand, there were 9 babies that weighed less than 2. So what you do is you plot this y against the end point of each interval. Let me rephrase that again. So what you're doing is you're plotting, this is your x value, but you're plotting each one of these endpoints, the upper bound of that interval. These x's go with these y's of the cumulative frequency to make a coordinate. So for example, this coordinate here would have been 2, 9. So the cumulative frequency is your y value, and the corresponding x's, okay, go with those y values, but they are the x's at the end point of each of the intervals. So I get all the coordinates, remembering that this is this 1.0, which is the lower bound, okay, this is going to cut the x-axis, which is known as the x-cut. So the lower bound is always where I start. So the very next point, I'm going to 1.5, and I'm plotting y is 2. So let's go 1.5, y is 2. So I would be over there. Let's go back up and plot another point. So when x is 2, y would be 9. Endpoint of the x against the cumulative frequency. So I'm at 2, 9. When x is 2, y is 9. Then let's keep going. When x is 2.5, y is 19. X 2.5, y is 19. And so what I do is, if this is an ogive, this is a smooth, continuous curve going through all the points. So it's one smooth, continuous curve, and it will generally make this beautiful S shape. Okay, and it will taper at the end because that's where it's going to end. Now, I have drawn this for you on the next page, but I want you to look at each point and make sure that you'd be able to sketch it. Remember, the endpoint of each of the x values is against the cumulative frequency. So let's go down and have a look. So there is my cumulative frequency curve. You can see I start off at 1, at 1.5 it was 2, at 2 it was 9, 2.5 it was 19, at 3, let's just see, where was it? When x was 3, it was at 33. So I could check something. When x was 4, the y value would be 50. So when x is 4, you can see that my y value is 50. I've got my curve. Now, it's almost certain that if you're going to draw the ogive, you're not just drawing it to draw it for its sake of a sketch. You're drawing it so that you can interpret it and you can read from the sketch. So most certainly there'll be questions that follow that say read off something, and you're either going to read off the cumulative frequency to find a value on the x-axis, or you're going to read from the x-axis to go back and find the cumulative frequency values. And in today's sessions, I've created a few questions where we're reading from sketches. So let's see, what does my question say? Estimate from your graph the median and the quartiles for the weights of the babies. This is the power of the cumulative frequency curve. It gives me one continuous curve so that I can read off values all over the place. So I want to find the median. I'm going to start off with the median. Remind me, what does a median mean? The median is the value that divides your data in two. So the median is the middlemost value of your data set. So I'm saying, well, if there are 55 babies, let me find the position of that middle baby. And one of the other things that I just want to draw to your attention, when you're reading off the sketch, you need to understand that everyone's sketch is going to be slightly different. This is an estimate, because what you're doing is you're plotting endpoints. And so because your sketch is an estimate, instead of reading off n+1 values, like you've learned in grade 10 and 11 to find the quartiles, for example, lower quartile, a quarter of n+1, the median, half of n+1, we actually take the nth values because it's just an estimate, and it's sometimes easier to just take those values off your sketch. So if I'm finding the median, the position for the median would be a half of the 55, which is n. And if I play around with that, that's roughly, I'm going to read off 27,5. So remember, you are going to read off. They want to know the weights of the baby. So I needed to end up somewhere on the x-axis. These are the weights. I know that I'm finding, if I've got 55 babies, I'm finding where is the 27.5 baby. Let me see if I can try and get this now. So I'm going to go to roughly 27.5. So I'm reading from the y-axis where I have the number of babies to go down and find that particular value, and I can see I'm just a little bit over halfway. If someone asked me what's that value, and it was one of my students, I'd say I can accept a few values. Roughly within the region, Q2, which is the median, is roughly about 2.8 kilos. So now I want to read off the quartile values. So it says read the median and the quartiles. Remember, you've got two quartiles, quartile 1, which is in the position which is a quarter of your values. And you've got quartile 3, which is the upper quartile, which is 3/4 of your values. Remember, these answers are not telling me the values of the quartiles. It is telling me where to look. So this is roughly 14. It's about 13,75. So I know that I'm going to take this off the y to go and find an x value, because this is how many babies, where it would be in the sorted babies. 3/4 of the 55, so I'm looking at the top end, the upper quartile, that is roughly 41,25. So again, I'm going to take this y value and go down and find the x. So let's go do that. I'm looking at about 13.75. Okay, 13.75, it's a little bit over halfway. Remember, this is a quarter of your data values, and then if I read down, I'm going to have to say that is about 2.2. It's a little bit less than halfway. Halfway is 2.25, so I'd say roughly 2.2. Okay, and then I'm just going to read off. I'll write those values now at about 41.25. So there's 41.25. Again, I'm going to read. I'm going to come back down off my graph, and I can see that that is very close to 3.5, I'd say roughly 3.4. So let me write those values down. It's so important that you work accurately. Use a ruler when you're drawing this on your graph. So the Q1 value is going to actually be roughly 2.2 kilograms. And the Q3 value we said was about 3,4 kilograms. please remember you're going to be reading from your OJAV sketch. And it's important that you realize which way you're reading. So when we're talking quartiles or values, how many people, that's off the y-axis, the cumulative frequency. That gives me the weights or whatever category I had. If they said what percentage of babies are above a certain weight, you'd go from the weight and go back and read off the y. And we'll have to read both ways. Let's look at my next question. So I've drawn the graph, and now it says calculate an estimate for the mean weight and the standard deviation of the babies, rounded to 2 decimal places. Now, when they say calculate, unless they say anything otherwise, use a calculator. Let your calculator work it out for you. This would probably only be worth 2 or 3 marks or so. So let's go and look at the table, because I need the table of values. The cumulative frequency is used for the OJAV only. So when you're drawing an OJAV, you need the cumulative frequency. But if you're calculating an estimate for the mean, if you're calculating the standard deviation, you're working with the frequency. So let me pull up the calculator and let's have a look. So I'm going to play. I just want to show you, go into stat mode, because of course we're in statistics and all the functions that we need on the calculator are there. Click on stat mode. I'm going to 1 var. Okay, so when I go into 1 var, oops, I've got a problem. You see, I've got x values, but I don't have a place to put the frequency. And I need to be able to enter roughly this table as it is. So I didn't know that was the case on this calculator, but it's presented me with a wonderful opportunity to show you what you should do. So all of you, please get your calculators out now and follow me as I press buttons on the screen. I'm going to show you how to add a frequency table or a frequency column. So you need to go to Setup. So Shift, Setup. Now, you're not going to see anything stats on that page, so scroll down. When I scroll down, over there at 3, it gives me an option for Stat. So when I click on 3, okay, let's click on 3, it says, do you want the frequency on or off? I'm going to say I want the frequency column on. Now, unless I change the setting, the frequency column will always be on this calculator. For every question I ever do in stats, the frequency column stays on. Leave it on. If you didn't need the frequency column, it won't make any difference. However, if you need the frequency column, it will be there. And I'm going to show you how your calculator will change shape now. So let's look at this. I'm going to go back into stat. Okay. So I tell it, oops, I don't want to shift it. So let's go into stat. When I go into stat mode, I'm going to 1 var. And look there. I now have the frequency column. So I can go and type in all the frequencies. 2, press your 2, press equals. Equals is your way of pressing enter. It's like on a calculator, whatever. The equals is enter. Press 7, equals, that's great. Press 10, equals. You'll notice that I went to the right-hand side because I'm avoiding what's happening on the left. Let's look at the left and say, what is the x value that I put in? Because I've got a boundary of values. This is an interval. It's bounded on the one side with 1 and bounded on the other side with 1.5. The question is, what is the x value? And so what you would have been taught in grade 10 and grade 11 is when you have an interval and you're calculating an estimate for the mean or the estimate for the standard deviation, you take a point estimate, which means you take that midpoint. So you're going to take the midpoint of each of those intervals as your x value. So I'm going to work out the middle value here is going to be 1.25. So I type in 1.25. For me, I find it much quicker to actually go all the way down and then to move across. So I'm going to type in all the x values. So the midpoint of the next interval is 1.75. And once you've calculated a few, you should be able to get there very quickly. Okay, then I'm what? 2.25. Just shout them out at home for me if you don't mind. Your parents will think you're crazy. I understand you. So this is 2.75. Keep going down. 3.25. The next one, I'm between 3.5 and 4, so that's 3.75. And then between 4 and 4.5 is 4.25. Enter that. The next thing says above 4.5, but there's nothing there. So I actually don't need that. That was unnecessary. It's irrelevant information. Now I'm going to scroll across and go all the way back up to the top, and now I enter the frequency. So the first one was 2. Just make sure that they correspond. Second one was 7. Then it was 10. Then it's going to 14. Enter. So I'm overwriting those ones. Then I go to 9. Enter. Then I'll go to 8. Enter. And then I'll go to 5. Enter. And that should be everything, which it is. This is where you've got to trust me. So we enter all the data through the stat mode, and now we're going to press all clear. And it's going to look like you've lost everything. But once you've entered everything into the calculator, it swims underneath the surface in that calculator, and it waits for you to access the data and do something with it. So you always enter it through the stat mode. Now look on the screen. What I'm going to do is I'm going to press all clear, and I lose everything. But I don't. It's all inside the calculator. So you enter through stat mode at the top. Now, if you go to the button number 1, above that is stat. That is how you access all of your answers, all of the data, anything that you need to have done with the statistics. So I go to shift, and I go to stat, and now it gives me options. Just for what it's worth, I'm just going to show you, if I went to 2, that shows me all the data. So I can see it's all there, and if I'd made a mistake, I can modify it, I can edit it here. All clear. Let's go back. So we get to our statistical data the same way every time. Shift 1, which takes you to the stat. Now, one of the most important things here is this var. And this var contains all the important variables that we will need. So if I click on 4, now you should see, for example, this n. Now I'm going slowly, so I'm going to go into n. Think about what n might mean. It gives me 55. N is the number of data values that we had. The number of babies in this case, n is 55. Okay, that's just reassuring for me. It means that I've typed this in properly and I haven't missed out anything. I go back again, shift, stat. So the more you practice, the quicker you'll get there. Now I'm going to my var. And then option 2 is very important. That x bar is the mean. And remember, we were finding an estimate for the mean. You might think, oh my word, the mean is 0. I haven't pressed equals yet. So I'm calling up the mean, press equals. There is my mean. So I'm just going to go down now. Okay. I'm going to need to call back my calculator. So my mean is 2.84. And of course, I'm rounding to 2 decimal places because that's what the examiner said. But you have got the standard deviation also in that calculator 1 button away. So go back to the var. So I press my shift, press my stat. I'm going to var, and there I'm going to find the standard deviation. And the standard deviation is option 3. On some calculators, it can look slightly different, but you're looking for that funny, like, circle thing. It almost looks like an apple with a stalk. That's a Greek letter called sigma. Okay, so you're going to click on that 3 and then press equals, and this is the standard deviation. And so what I'll do is I'll say the standard deviation, if I'm going to 2 decimal places, 0.798, it rounds up, 0.80. And so there we've got the standard deviation. Now, hopefully, this has jogged your memory and it's reminded you of all of the grade 10 and 11 statistics that you need for grade 12, but you've done this and you should know this, and you just need to practice to get on top of it. We're going to now break. Hopefully, you have a good break. Come back rested, and we'll continue with today's lesson. See you shortly. Welcome back from the break. We're going to dive straight into our next question. We're going to look here at question 2 in your pack, and here we're looking at the 5-number summary. We're going to look at box and whisker, and we're going to talk about the quartiles, interquartile range. So let's dive in. Here we've got the IQs of 27 15-year-old girls, and we're asked to find the 5-number summary. This really should give us easy marks in the exam. It's there to help you if you've done some revision. Remember, the 5-number summary is made up of 5 parts, hence it's called the 5-number summary. So we want the minimum, we want the lower quartile, we want the middle quartile, but the middle quartile is the median. Okay, so I can abbreviate it as Q2. I want the upper quartile, which is Q3, and then I want the maximum. So it's the minimum, and then the 3 cuts to divide your data into 4 equal partitions, and then the maximum. So this is sorted. So this is really great. Minimum, 90. Maximum, 116. Now I'm already getting myself some marks. There were 27 students. Okay, so remember that if n is 27, to find the position of the lower quartile, remember we're talking position, not the value. All that I do is I say that would be a quarter, so this is position of n plus 1. A quarter of 27 plus 1. And a quarter of 28, well that works out nicely, is a 7th value. So all I've got to do from my sorted data is count the 7th value. So 1, 2, 3, 4, 5, 6, 7, and that there is my Q1 value. Then I'm going to do the same. Q2, you could have, of course, cross off until you find the middle values. So the median, remember the median is a half of your data values. So it would have been a half of 28, which is the 14th value. Well, if I'm already at 7, count another 7, 8, 9, 10, 11, 12, 13, 14. So that there will be my Q2, okay, which is 100. And of course, hopefully by now you'd know, we'll go another 7, because you're going up in 7s to divide your data. But again, if I played around and I said, what would 3/4 of 28 give you? Well, 3/4 of 28 is 21. Find the 21st value, but I'm just going to count another 7. 1, 2, 3, 4, 5, 6, 7. And so over there is my Q3, which is 103. Finding the 5-number summary shouldn't be difficult. Sometimes you would do it from a table of data. Sometimes it's not sorted. So always remember, you must sort it first. Sometimes it could be from a stem and leaf. But the nice thing about a stem and leaf, it's already sorted for you, and then you just count along the way. The next question says, use your answer to the question above to draw a box and whisker plot. Now you must remember that a box and whisker plot is a scale diagram. The whole idea is that you're trying to interpret the sketch afterwards. So if you draw it beautifully symmetrically and the data doesn't represent that, you're going to infer something incorrectly. So it's a scale diagram. Make sure that you get the whiskers at the right place, put the box at the right place so that you can read from it. So my minimum was 90. On my scale here it goes 89. So that there would be my 90, which is my minimum. Then I'm going to Q1. Q1 is at 94. So there is my Q1. Q2 is at 100. So there is 100. That's my Q2 or my median. Q3 is 103. So that there would be 103, which is Q3. And where's my maximum? My maximum is at 116. 14, 15, 16. There we go. Now that wouldn't be sufficient and you can't get marks, but I'm going to put it all together. So remember the box part, okay, and do this with a ruler so that the examiner can be impressed. The box part is going from Q1 to Q3 with the median down the middle. That is showing me exactly the position which divides my data into 2 halves. Okay, so that's the middle of my data. And then I've got the whisker parts. And the whiskers show me how far this next 25% of my data extends beyond the quartiles. So I can see over here, this part, let me choose another color, this whisker there is significantly further than that whisker over here. And that's important because then we can interpret our sketch and see what's going on. Almost certainly, the box and whisker sketch is for you to interpret something. Calculate the interquartile range. The interquartile range is the range of your middle 50% of data. So RQR is always whatever your Q3 value is minus whatever your Q1 value is. So the Q3 value, I worked it out, but I can read from the box and whisker, is 103. Minus the Q1 value is going to be 94. And that's not too difficult. That will give me 9. So that interquartile range is going to be 9. And now this question, which is my final question, says, is the data positively or negatively skewed? Justify your answer. When we're talking about skewness, what we're really saying are the outliers or extreme values pulling the mean in one direction? And the direction that they pull the mean in is the direction in which the skewness occurs. So the median is here in the middle, but where the whisker or the box is much further to one side, we say it's skewed in that direction. So we actually skewed to the right. These extreme values, which may or may not be outliers, but they are the extreme values, have the effect of pulling the average, the mean average, to the right. And when the mean average is pulled in one direction or another direction further than the median, we have skewness. So this would have been pulled to the right because from the median to the whisker, it is significantly further than from this median to the other whisker. And so we'll say this is skewed right. And then I would say something to the effect that the distance from the median to the right upper bound, or the distance from the median, to the max is much greater than the distance from the median to the minimum. So it's much further on the right-hand side. To the max is much greater than the distance from the median to the min. Almost certainly you're going to have a question where you have to interpret the box and whisker. That's why you draw it. That's why it's a visual representation of your data that tells you so much from the visual. Okay, that takes us to the end of question 2. I now want to look at the grade 12 statistics. And the grade 12 statistics took grade 11 and grade 10 scatter plots and made it scientific. What we did is we worked out an exact equation for the line of best fit. Let's look at this example. The following data is a summary of the number of bags of compost used to cover an area of ground in square meters. Okay, so these are the number of bags of compost. So number of bags, and this over here would be the area. And so we can be asked to draw a scatter plot. Now drawing a scatter plot is not too difficult at all. You've just got a whole lot of coordinates. So we plot the points. So the first point is x is 15, y is 35. So I'd go, where is x 15 there, y is 35. So I'd go to the end and I'd plot that point. And so we end up plotting a whole lot of points. Let me plot another point. When x is 6, y is 18. X is 6, y is 18. So there's 15, 16, 17, 18, just a little bit over halfway. And I would plot all these points on the set of axes. So draw a scatter plot. Easy, easy marks. You've got to get full marks for this particular component of the question. What I'm doing is I'm diving in here because to save time, I've drawn all of the points. So the points are in yellow on your screen. So I've got a point there, 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 and I've plotted all of those points. Don't worry too much about the rest. It was just me getting the computer to help me with the questions that follow. Part B says find the equation of the best fit line rounded to 2 decimal places. So what we do is we work out scientifically what line would best fit this data. So what straight line would go through as many points as possible or be as close to all of the points as possible. Now if we had to do that on a ruler, all of us would get a very different answer. But when the calculator does it, it does it scientifically to give you an exact answer that best matches the data. And that's where you need your calculator again. You are expected to do it on a calculator. It's not, will you have to do it manually? Never, you do it on a calculator. So we've got to go back to our calculator and enter all the data. But I just want to remind you that we're finding a straight line, y equals mx plus c. But in statistics, this straight line looks quite different. It is still a straight line. There is still a coefficient of the x, which tells me the gradient. There is still a y-cut or y-intercept, which is the constant on its own. But on the calculator, it's given as y equals a plus bx. For some reason, statistically, we write the equation in a slightly different format. And when you're finding the line of best fit or regression, your teachers might not stress it, but we put this little cuppy, this little hat on top of it, and we call that y hat is equal to a plus bx. Now, I am going to go and enter the data into my calculator. So let me pull up my calculator. Let me clear it. I'm going back into statistics. So remember, we're going to get into stat mode. So I tell it, let's go into stat. Now, when you are doing every bit of statistical analysis and you're pulling up all the variables, you always go to 1. 2 is for the regression line. And have a look at it. It gives it to you in the form a plus bx. So you must know you were finding the line of best fit, the regression line, the least squares line, the different names for the same thing. It is a plus bx. That's what you're pulling up. So press 2. And what the calculator does is it gives you an option to enter coordinates. The frequency column is there from earlier. It will always be there. It makes no difference whatsoever, so don't panic. So I'm now going to enter my coordinates. I find it quicker to enter the x's and then to come back to enter the y's. So again, as before, please, if you can call out those numbers for me, it'll help us go a bit faster. Put in the 6, put in the 10, put in the 18, put in the 9. Let's move across a little bit. 7. Remember, every time you press equals, that is you entering. 14, 11, 5, and 8. Oops. And then I must just go across and make sure that I enter all of the corresponding y values with each of those x's. Just make sure you do this carefully. I'm lining it up with 1 because that was the first coordinate that I had. So now I'm going to put the y's. First y is 35, 18, 24, 32. Oops, I can see I made a mistake, so let's just go back. I can edit it, and I can tell it now, let's put in 24. Now, like before, I've entered all the data into the calculator. You can just press AC. Everything is gone, but it hasn't gone from inside of the calculator. Now what we need to do is we need to access our data. So remember, we go back, press your shift, okay, we press the stat, which is that 1, and we get this option here, which is regression. And we haven't had that before because we weren't working with linear regression. Then I hit 5, and that regression gives me a couple of options. It gives me A, it gives me B, it gives me R, and some other variables that we're not going to do today. So when I play with the A, remember from the equation, A is the constant part. So I'm going to go and work out. So press your 1, press your equals, and that A should be 9,3666. If I'm going, as the examiner said, to 2 decimal places, then it's going to be 9,37. Plus, then I'm going to go and work out what that B part is. So again, AC, or clear, shift, get yourself into that stat mode where you can retrieve all of your information. Go to reg, go to B, which is your gradient, press equals, and that's 1,5 to 2 decimal places, a 1,52. And there is my regression line, or my least squares line. Now, we will often go and use that. So they will say to me, estimate something. If they are asking you to estimate, never go and use one of your coordinate values. You don't know whether your coordinate value was actually an outlier or not. The least squares regression line is the best line to match your data. So when you are calculating and estimating, either work from the line you've drawn or from the equation. So if they are telling me estimate the area, remember the area was y, so I'm trying to find a y based on a specific x value. So we say y hat would be equal to 9,37 plus 1,52 multiplied by 16. And there I need to use a calculator, unfortunately. So let's go put it in, 9,37. And that's added to 1.52. And that was multiplied by 16. And what that gives me is 33.69. and that what is the area that it covers? So it's 33.69 meters squared. Perfect. And then they say to me, draw in the line of best fit showing 2 significant points. So let's go back to my sketch because I've drawn it for you already. But when you need to draw a straight line graph, you need 2 points. And so you need to substitute any 2 points to go and draw the graph. So look over here. If the equation was y is equal to 9,37 plus 1,52x, it's not too difficult to go and find any 2 coordinates. You can substitute, like we have just found 16. That's a coordinate. You could have plotted where x is 16, y is 33.69. So let's go where x is 16, y would be 33.69. There we go. And that is the point that I used because I just calculated it. So you can see that I've drawn it. My blue points are the points that I calculated. You could find the y-intercept, 9,37, and plot that. You could choose any x value. So I needed to show 2 points. But I just want to bring to your attention why I've chosen that particular point. So again, the question said draw the line of best fit, show 2 points. We've spoken about that point. That was one we generated. I want to talk about that particular point. If you find the mean of all of the x's, so all the x points added together and averaged out, and if you find the mean of all of the y's, and remember that bar stands for x bar, y bar, the average, that particular point will always be on your line of best fit. And I just wanted to show you, if I go in now, so if I go shift, stat, and I'll go to the var, because now I'm going to pull up an x bar, and you saw it was there earlier. So I go to 4, and I pull up x bar, which is 2, and I say equals. It tells me at 10.3, that's what your x bar is going to be. And let's go and find out what that y bar is. Shift stat, go into there, go to the vars, go and find y bar, which is 5, plot that in, which is 25. This particular point will always be on your line of best fit. So for me, I don't even have to worry about calculating it. The calculator throws it out. So 10.3, I'm just to the right of 10.3, 25, there's my point. That is on the line of best fit. Okay, so we've drawn it. You need to be able to draw it scientifically. But from grade 9, you've been drawing graphs. Just substitute any nice 2 points, put it in, you've got the graph. Now, the final part of this question says, determine the value of r. Now, r was that other variable that's on your calculator, so we're going to go and find it. So let me pull it up, let me work out the value, and then we're going to interpret what r means. Okay, so we'll go back in the calculator. Remember, we don't want to re-input the data, we want to access the data. So I go to shift to that stat button to access my data, go to regression, because it's part of the regression stuff, and you're going to option 3. When I go to option 3, it gives me a value for r. And then I say, well, r is 0,937. I don't think the question said how many decimal places. No, it didn't. So I'm just going to go to 2 decimal places. Now, this is very important. Think of this as a percentage. Okay? If r was 1, that would be 100% accurate. So when r is 0.94, that's saying to me it's 94% accurate. Think, if you were getting 94% in your matric exam, you'd be fairly chuffed. So 94% is a very strong correlation. What r tells me is how reliable is your graph, the line of best fit that we've drawn, in terms of the x being able to predict the y values. So we might have a graph that is nowhere near the points, and then it wouldn't be a very reliable predictor. But when your graph is near the points, this r value tells you how accurate the graph is going to be. So the r being much higher tells you it's a better predictor, and r being very low, as close to 0 as possible, means that there is no correlation whatsoever. So remember that r talks about the correlation. Okay, how close the x correlate to the y in terms of this line of best fit. It is the correlation coefficient. but there are two components to the R. First of all, the sign. R is positive, so it is a positive linear correlation. So the sign is always part of the answer when you do an interpretation. And then the second part is we say, well, how strong is it? We would say it's a very strong correlation. Okay, it's a strong, or you could say very strong correlation. So there's always two parts. Please remember that you're always talking about the sign, because a negative correlation would have just meant that you were going the opposite direction. So positive correlation talks about an increasing function. There is a positive correlation, so you always want the sign, and you also need to include in your answer the strength. And think percentages. 94% very strong. Below 70%, you would say it's fairly good, it's okay. When I'm getting closer to 50, we would say weak or very weak. So we can talk about weak, very weak, fair, moderate, strong, very strong, based on that value. But again, I'd encourage you to look at the guideline notes that accompany this section. That takes us to the end of this question. We're now going to break for a short while. Recharge your batteries. We'll see you shortly. Hello, welcome back. We're ready to tackle our last question. This question I've taken from the IB exemplar because it's a beautiful question that summarizes everything that you need to know in terms of the data handling. Let's dive straight in. It says the speed of 50 motorists were recorded on the N3 between Durban and Johannesburg. The speed limit on this particular stretch of road is 120 kilometers per hour. The ogive curve showing the relationship between the speeds of the cars versus the cumulative frequency is shown below. So there we go. I've got an ogive curve. I can see if I said to you what were the lowest speeds, remember we always start the ogive at the lower bound of the first interval. And if I had to go along over here, I know that there are 50 cars because that's where the cumulative frequency would have ended. Let's go find our question. How many cars were traveling within the legal speed limit of 120 kilometers per hour? So this is a perfect illustration of where we're reading off an ogive, but now, because we've got 120, I'm reading off the 120. So let's go and get my ruler, and let's go up here to 120. Okay, I'm slightly off. And then I would go and read, and let's just see, 31, 32, roughly 33, but I think I just need to move it up fractionally. Oopsie. Okay, I'm not managing to get my line up, but it doesn't matter. When the examiner marks this, they work within a slight variance, so you can be slightly off, but not much. So how many cars are traveling? Well, I know that up to that point, lower than the graph, is 33 cars. So any cars traveling more than 120 are above the 33. 33 down is traveling below 120. So if they say how many cars within the legal speed limit, I would then say 33 cars. Then it says, what was the median speed? So now I'm going to go and read off my graph again. So if I'm trying to find out what a speed is, it means I've got to read from the y to come back down to the x. So the median speed, if I've got 55 cars, I'm going to try and find out roughly where I'm going to read off. Let me just see, was it 55? No, it's 50 cars, my apologies. So I'm going to read off, if I got 50 cars, I'm roughly reading off where would the 25th car would it be. So I go to 25 cars, I go across, I read down. It's just after 110, so I would say roughly the median car is 111, and I'd be happy with that answer. 111, remember your units, 111 kilometers per hour. Perfect. Then it says, above what speed were the fastest 25% of drivers driving, and which quartile is this represented? The fastest 25% of my data. So now I've got to think very carefully. You know, if you've got the cumulative frequency, and if I go halfway, that's the median. If I go up 25%, up to that point, that 25% is the lower quartile. Go another 25%, I've got to the median. Go up another 25%, so I'm 3/4 of the way through, That's the upper quartile. So I'm trying to work out what the value of the upper quartile is so that I can read off my sketch. So when it says which quartile is represented, I can quite comfortably say this will be Q3, or you can also say the upper quartile. And now I'm going to have to go and read that value. So I'm going to say, where would 3/4 of 50 be? 3/4 of 50 is roughly 37.5. So I'm going to go to my sketch, and now I'm going to read off 37.5. So 35, 6, 7, 37.5. I'm a bit down. Come back down over here. And so when it says what is that value, it's over 120, just below 125, so roughly about 123 kilometers per hour. So I can go and give that answer over here, and I say that would be about 123 kilometers per hour. Let's continue with this question, because it is a big question with lots of marks. So we carry on. And it says, if the lowest speed recorded was 62 kilometers per hour, and the fastest speed was 158 kilometers per hour, draw a box and whisker plot of the data from the ogive. So we've done a box and whisker earlier on. Remember the lower bound, there's my 62. Let's go to 158. There's my 158. So I've got my min, and I've got my max. And then I need to go and find the actual values. So I need to find out what was Q1, what was Q2, which is the median, and what was Q3, which was the upper quartile. So I'm just going to go back. I can't remember if we've calculated these. Yes, we did find the median, which was roughly 111 kilometers. So I know that the median is 111. We'd also found the upper quartile. So again, remember the upper quartile we read off, which was about 123 kilometers. But this is a bit of a sneaky question because we never calculated the lower quartile. So I'm going to have to now go and read it from the sketch. But I can do it over here while I've got the sketch in front of me. Remember, I'm taking a quarter of 50, and that is going to go and give me that 12,5. So I'm going to go and read off. Where is that? It's roughly about 100. It's a little bit past the 100. It doesn't show on your screen, but it was a bit of a fraction past. So roughly 100, 101. Now I can go and plot this. So Q1 is going to be about 100. Q2 is going to be 111. Q3 is 123. 1, 2, 3. There we go. So create the box. Remember, it's scale diagram. There's your Q1. There's your Q. More haste, less speed mark. So let's go. There's your Q2. There's your Q3. And then join the whiskers. And there is my box and whisker. I hope that today's lesson has been useful. I hope that you've now become a statistics master and that data handling on paper 2 has become really something that you are exceptionally good at. All that I need to do now is wish you all the best with your revision and good luck with your final exams. From me, Mark Ancelotti, goodbye and good luck. And in grade 11, you worked with grouped data. So remember, grouped data, we played around. You could find an estimate for the mean. You could find a median interval. You're playing with intervals. You could find the standard deviation of grouped data. Now, I mentioned standard deviation. That's one of the other things that we have to do. That was introduced in grade 11, but it's examined in grade 12. Standard deviation and also variance, which is just the square of standard deviation. Remember, the other thing that we've got to do is the 5-number summary. So you either have to calculate it or you have to represent it graphically, and that's in the form of a box and whisker plot. Box and whisker, as early as grade 10, you've been playing with them, but in grade 11 and grade 12, we talk about more interesting things like the skewness of your box and whisker plot and read certain things from there. Then, of course, with grouped data, we will often work out something called the cumulative frequency, which is an accumulation of the frequencies up to a particular point in time. If we graph the cumulative frequency on the y-axis, we get something called the ogive. And so we have to draw an ogive, and more importantly, you need to be able to read off values from an ogive. And that is an important concept. Again, grade 11 examined in grade 12. One of the big things in grade 12 Hello there, welcome to another one of Learn Extras exam revision sessions. I'm Mark Ancelotti, and today I'm going to be working on statistics with you. Remember, statistics is now in both examination papers, so we're doing a little bit of paper 1, a little bit of paper 2. Really our focus today, data handling of paper 2. So let's dive in. If I just remind you that there are study notes that accompany this TV session, so try to get hold of those, work through those examples so you can make sense of what today's all about. Okay, so here's just a bit of a checklist. Remember that statistics has been divided up in the new CAPS curriculum into paper 1 and paper 2. Paper 1 contains probability and counting techniques. Paper 2 contains all the data handling, and that's what I'm really going to focus on today, is the paper 2 data handling component of statistics. For me, the data handling can be divided into 5 little components, and you're probably going to get a bit of every one of them. So let's just see how we divide it up. In grade 12 is actually determining and sketching the line of best fit. Now that's sometimes called a least squares regression line or residual line, the line of best fit. You have to be able to calculate, using a calculator, that equation for the line of best fit. You need to be able to draw it on a set of axes on your scatter plot, and you also need to calculate the value of R. R at school is Pearson's correlation coefficient, so we interpret and play with that R value. Now, all of these concepts are going to feature in the 4 exam questions that I put together for you today. So let's dive in and see how we do with those exam questions. This first exam question is a huge question. So there is a huge amount here, but it's revising many of the concepts from grade 11. So let's see what we're going to do here. I've got a frequency table, and this frequency table gives the weights of the first 55 millennium babies born in a city hospital. And the really nice thing is I can see the total at the bottom of the frequency column. And then over here, these are intervals. So these are different weight intervals. So anything between 1 and 1.5, between 1.5 and 2.0, and so on. And so generally for continuous data like we have here, we put in intervals and it's grouped. So let's find our questions. The first question says to me, calculate a cumulative frequency table. So a cumulative frequency table, so what I'm going to do is I'm just going to actually use the space over here. It's the cumulative frequency, and I'm going to go and generate some values. So the cumulative frequency is an accumulation of all the frequencies up to that particular point. So what we're saying is how many babies are between 1 and 1.5? Well, 2. Now look carefully. What should be happening here is we're saying how many babies were in weight below this final value. So how many babies weighed less than 2 kilograms? So it's everything up to that point. So it would be the 2 plus the 7, which then makes 9. Now when I get to the next one, what we're doing is we're saying how many babies were actually below 2.5 from that lower bound up to there. So it's always saying what's the running total, what's the accumulated frequencies up to that point. And the nice thing is if this is always the total up to a point, all I have to do is say, well, add the 9 to the 10 and I'll get 19. And then add that 19 to the 14, and so I can go and work out the cumulative frequency. Just be aware, I've seen many nice exam questions where the examiner will give you partially completed table with some frequencies, some cumulative frequencies, and you have to go and solve for unknowns by working backwards or forwards. But to save a bit of time, I've already completed this cumulative frequency table. So let's go have a look here. If you've been working through the handouts that accompany this lesson, hopefully you've got exactly the same answers here. For me to know that I've done this correctly, the final value in the cumulative frequency table should always add up to the sum of all the frequencies. So the n value is the cumulative frequency. Now, if we are talking cumulative frequency in the examination, almost certainly you're going to go and draw it. When we talk cumulative frequency, I want you to immediately associate ogive. The ogive is the visual sketch representation that links cumulative frequency to your actual weights. Now, I've got a set of axes and I'm asking you to draw the cumulative frequency curve. And many students will go and start off at 0 there. And I'm saying, please don't ever do that. Sometimes you will need to go there, but other times you don't.